Hi, good day, everyone. Thanks for joining us on the stream today. I'm Nicholas Mendez from GDG Port of Spain, and we shall be starting our Firebase study jam session. So you can see on the side here, we have several items on the agenda. First, we're going to do an introductory just to give you a nice overview of some of the features that we'll be looking at today in Firebase. Then we're going to have a code lab on hosting and performance monitoring, followed by a code lab on extensions. Then we'll take a little break for lunch, what have you, and we'll come back with our specially invited guest speaker, Arthur Thompson, to give a demo on Firestore functions, and then we'll wrap it up with another code lab on push notifications. So thanks again for joining us today, and we're gonna dive right into our first presentation. Sorry about that. I noticed that when I remove my video stream, I also remove my audio. So I'm just going to start back from the top. Okay. So what is Firebase? Firebase is Google's client-side application development platform with a mission to help app developers of all sizes, large or small, to succeed with their products. Firebase accomplishes this by taking common problems that occur during a product's life cycle and making them easier to solve, be it by providing more information about your products or providing tools to handle complex problems like security or network connectivity when storing data. Firebase is divided into three main categories of tools with specific goals. The first one helps you build better apps by making complex coding processes easier. Then, uh, then the second section allows you to improve app quality by helping you catch issues early and fixing them quickly. And the third section helps you grow your app by understanding how other people are using it and engaging them in a meaningful way. As you can see here, there's almost 20 different products within Firebase. While it may seem like a lot, and we're going to go through some of them, the average developer will only use a handful of them in each app. The goal isn't to overwhelm you, but rather let you know what's available when you need it. So in order to help developers use these tools quickly and easily, Firebase has provided a variety of SDKs or software development kits. Some of the more commonly used SDKs support both iOS and Android mobile developers, a JavaScript SDK for web developers, and a C++ and Unity SDKs for game developers. For detailed explanations on how to use these SDKs and in-depth resources will be discussed at the end of the presentation. So as mentioned earlier, Firebase products are divided into three main groups. The first set, we'll go over the backend as a service products, which help you build apps faster and more easily. One of the hardest things to get correct in an app is security. Luckily, Firebase has you covered when it comes to protecting your users' data. Firebase Auth is an out-of-the-box authentication UI that is optimized to give your users the best experience when logging into your app. Firebase authentication works with a number of different third-party identity providers, including Facebook, Twitter, Microsoft, Yahoo, and more, in addition to Google's own identity services. Additionally, you can support custom email and password solutions, anonymous accounts, account linking, and phone number authentication. Once your user signed in with one of these services, Firebase assigns that user a record within its system. This includes a unique user ID and a signed token, so you can get a consistent representation of your users and one that you can use against both Firebase services and your own custom servers, no matter how they sign in. So all it's saying is that when users use these different sign-in methods, a unique ID is generated, so you will know which user is actually logged in or which user you're actually talking to, and you'll use this ID within your service and your application. So our first product we're going to talk about is the Cloud Firestore. And it is a database tool that allows you to group data using document collection structures for straightforward access. So it kind of looks a lot like JSON, if you're familiar with JavaScript object notation. It's collections, but they're more or less arrays and objects. This data is stored and synced between users and devices at a global scale using a cloud-hosted NoSQL database, which also supports basic queries in addition to direct data access. The goal of Cloud Firestore is to provide a backend data storage solution without having to go through the tedious process of setting up your own database server, authentication schema, REST endpoints, and everything else that goes along with building a typical database infrastructures. More importantly, Cloud Firestore will automatically scale with your apps. As your app becomes more popular, additional machines will be added to your project, so you don't need to worry about failing to support your users. And it will also provide access to an offline version of your data if your user happens to lose the internet connection while using your app. While Cloud Firestore is great, it's not the only solution available for storing your data with Firebase. So just for a historical story on this. Before Firebase was bought over by Google, the main service is what they're talking about in this slide, which is the real-time database, which is similar to Firestore, except they don't really use collections. They just use a JSON tree structure. So there's no arrays, just nested JSON objects. So the real-time database uses a simple JSON tree structure to store and access data. While more lightweight than Cloud Firestore, it still offers many of the advantages, such as real-time data syncing. So the Cloud Firestore is real-time, but the real-time database is even more real-time. The reads and writes are even quicker. Offline support and scalability. Additionally, Firebase real-time database supports the ability to know when users are connected to the database and can be used in conjunction with Cloud Firestore, as each can serve its own unique purpose within your app. So although real-time database and Cloud Firestore are great for storing more primitive data, sometimes you need to store and serve user-generated content, such as images or audio files, directly in your mobile app. Using cloud storage for Firebase, you can do exactly this with some additional features to make your app even more robust. Uploads and downloads are handled by the Cloud Storage SDK or resume. Uploads and downloads handled by the Cloud SDK are resumable, making them more resilient to changes in network connectivity. When a user's connection is disrupted during an upload, the SDK will automatically handle retrying and resume, which can be critical when dealing with the kind of network conditions often encountered on mobile devices. Downloading content uses a similarly robust system, allowing users to receive their data once a connection is successfully reestablished. Once the user's content is uploaded, it can be shared with other users of your app using the same SDK. And sorry, and since you will likely run into situations where the only certain users should be able to see or upload specific content, you can use Firebase security rules system along with Firebase authentication to restrict content according to your app's requirements. Cloud functions for Firebase are single-purpose JavaScript functions that are executed in a secure, managed Node.js environment within your Firebase project. They are powerful tools that let you handle complex logical operations from within Firebase, such as performing operations on your Firebase database or interacting with various other Google external services. Cloud functions can also respond to events generated by other Firebase project features, such as authenticating users, updates to Firestore, or the real-time database. Files being uploaded to Firebase storage, analytics conversion events, or pub/sub events from the Google Cloud Platform. They can also be triggered by direct HTTP requests if you want to call a particular function directly. Like everything else in Firebase, Cloud Functions will automatically scale to meet user demand. This means that even if your app is an overnight success, Firebase has you covered. Fortunately, you only pay for the services that you use. So if you scale down under the quota, you don't pay for using Firebase functions. So one example is that Firebase has different pricing plans. So even if certain features are hidden behind the billing, you still won't see any charges for a certain amount of requests. So example, if one of the code labs we'll be doing today is on Cloud Functions, and even though I need to upgrade it to the Blaze plan, I won't see any charges at the end of the month, because in order to actually see charges, the number of function invocations need to exceed over 1 million requests. So for the first million every month, it's free, which I think is rather generous. So while Cloud Functions for Firebase are incredibly powerful, sometimes you just need a solution to a common problem. Luckily, Firebase extensions were released at the Firebase Dev Summit last summer, or it might be the summer before that, September, sorry. Extensions are a collection of pre-made configurable functions to handle common use cases, such as resizing uploaded images, sending emails, or translating text to a different language. You can find a complete list of available Firebase extensions on the Firebase documentation page, or directly from the extensions page of the Firebase console. So Cloud Functions are just the environment that lets you write JavaScript functions, but extensions are collections of these functions already written by other people that solve specific issues. So I think they're really useful when you want to pull something together, because they're very common tasks you might do on the back end. So for example, URL shortening, things like translation, all those things are already written, and you can just drop it into your project. Nowadays, browsers are more performant and capable than ever. And front-end JavaScript frameworks like Angular, Polymer, React, Vue have simplified development, although that may be a subjective word, simplified, for rich app-like websites. Firebase Hosting is a developer-focused static web provider that is fast, secure, and reliable. Content is cached using solid-state drives around the world on content delivery networks, or CDNs, edge servers. And every deployed site is served over a connection secured with an automatically provisioned and configured SSL certificate. So it's just saying that you have static file hosting for your websites, and they'll already be on HTTPS. And I can tell you that they use HTTP version 2 as well. No matter where you are in the world that your users are, you can expect them to receive your web page or progressive web app quickly and securely. Best of all, Firebase hosting is easy to use with the ability to deploy a web page with a single command from Firebase command line interface. Now that you're familiar with all of the backend as a service products, you can start to see that the real value of Firebase comes from the fact that everything fits together to help you solve your day-to-day development problems. Firestore and functions will integrate seamlessly with authentication. Security rules will help make sure users are only accessing what is pertinent to them, and data in the Firebase storage can be referenced by your databases, to name a few examples. Combined, Firebase provides a powerful tool without a lot of complexity or overhead. Now that we have discussed the tools available to help build great apps, we can dig into how Firebase enables developers to understand how their users are interacting with them, and then improve the stability for a better experience. So now we're moving on to the second section of Firebase features, products. So the first one we'll talk about is our Firebase performance. We're not going to go through all of them. We're just going to just cover the ones that we're mainly looking at today. So, however, not every error in your app will be a crash or failure, right? So there's a service called Crashalytics, which helps mainly for mobile apps to get details about crashes. But since this event is more focused on Firebase for web, we're going to just talk about performance. So sometimes things will just be slow due to service, network, or location issues. Firebase performance was created to help you in these situations by logging start and network latencies, as well as allowing you to record custom performance metrics. These metrics are then reported back through the Firebase performance dashboard, where they are grouped by country, device type, app version, and operating system version in order to provide you with useful insights into the performance of your app. Firebase performance works not only on mobile apps, but is also the only product in the industry that currently provides real user metrics for free. So the final group of products from Firebase helps us grow their group base, your user base, and engage with the users in a meaningful way. So Google Analytics. Google Analytics for Firebase is at the heart of the features that help developers grow their apps. It allows developers to measure up to 500 different predefined or custom event types with up to 25 user properties per event. So that's just a lot of Google Analytics jargon. Won't be going much into that. We just be doing the simple things like logging their location or what have you. Google Analytics, information about demographics, retention, engagement, and revenue is also automatically collected in order to help you gain valuable insight to your apps. The best part of this is that all of analytics is free with unlimited use, so you only need to focus on how you can improve your apps. One of the many useful features of Google Analytics with Firebase is that developers can set custom user properties in order to understand how different users interact with the app, and multiple users can be assigned to an audience. Once an audience is established, you can modify in-app experience for another service that we won't really talk about today, called remote config. Changes. Targeted advertisements using AdWords based on previous user behaviors or trigger specific cloud functions. So it's just a lot of integration you can get here from the insight that analytics provides. Where Google Analytics really shines is the ability to export all of your collected data to BigQuery, which allows you to pull apart the data and analyze it in new and useful ways that fit into your unique data requirements. Next, we're going to talk about Firebase Cloud Messaging. Firebase makes sending push notifications to a user easy with Firebase Cloud Messaging. Notifications can be sent to Android, iOS, and web devices, and may be addressed to individual devices, groups of devices, such as audiences established on analytics, or you can have audience or users subscribe to topics, and then you could send those notifications to the topic. In order to use Firebase Cloud Messaging, developers must register a user's app instance with Firebase Cloud Messaging services. Then write code either on their server or through Firebase Cloud Functions to address devices based on ID, group, or topic before telling the Firebase Cloud Messaging server to send the message. Once the message has been sent, it will automatically report analytics information back to Firebase, such as if the user clicks on the notification to open the app. So now that you know the various features of Firebase, if you want to take a deeper dive into them, there's a lot of great documentation at firebase.google.com/docs and the official blog at firebase.google.com. So you can also find videos covering a wide array of topics on the Firebase from the Firebase team on the Firebase YouTube channel, and you can also follow them on Twitter. So thanks again for joining me for this presentation. That's our introductory overview. We're now going to go straight into our first code lab. So the way the code labs are set up, they are step-by-step guided tutorials to get you to do something, write some code, and actually build something in a technical way. But for this event, I will be demonstrating the code lab, and then after the event, we will release it to the general public. We also link a special workspace that allows you to complete the code lab all in the cloud. So we're going to go to that over here. So the first code lab we're going to look at is how do we use Firebase hosted, integrate Google Analytics and performance monitoring into a web app. Okay. So this is how the code lab website will look like. I guess you can, yeah, you can probably actually access it right now. So the first thing you need to do is create a Firebase project. So we link it here. Now we're going back and forth between the tabs. So you create a project, give it a name. Continue. We want to use Google Analytics for this lab, so we'll enable that. We need to select an account. So I guess we could create a new account. Demo project. Save. We can leave this location. We don't need to accept this or any of these, but we can accept this. Continue. So here it's going to create our project view. Oh, I'm seeing now we have some questions. Yes. Yes, yes. So I think we're gonna, while this is loading, I'm gonna just look at the questions in the comments. So how is the safety of extensions verified? It's a nice question. Well, I would say that I believe every extension is open source, right? So the entire Firebase team, as well as the open source community, can actually contribute, and whether there are security issues, they can be made on GitHub issues. But of course, that's the thing in open source. You know what you get. So it's not like it's a black box and you just need to trust the code is there. If you could go through the code and you don't trust it yourself, but you see an issue, you can file that issue before just dropping it into your app. Who owns the data? I would say that you own the data, but I'm not saying, yeah, I'm not too sure exactly the terms of service because I don't really read all these things in detail as I should. But I would believe that you own the data, but I can get back to you on that. Right, so our project is created. As our next step, it's going to look something like this. Right, so we want to create a web project. So you just click this button here. Look at the web app, my app. We want to set up Firebase hosted. So let's go ahead and click that. Leave it as this, just the app. Go next, next, continue to console. So I should be created now. That's it over here. And now we're going to open up into our cloud workspace. So this link, it mightn't work right now because I probably need to redeploy the site, but it opens it in a service called Gitpod, which is a really amazing cloud IDE because it's, for one, it's free and it gives you a whole Docker container to run Linux commands and install packages. So when you click this link and after it loads up, you'll be sent to this experience here. Let me just start the workspace. Okay, so this is how the workspace looks like. Of course, you can do this on your machine if you have the dependencies installed, whether it's Windows or Linux or iOS. But we're going to just use it in Gitpod. Now we're just going to demo this lab in Gitpod. First thing you want to do is log into the Firebase CLI. It's already installed in this container, so you just do that by entering this command. So just you don't need to try to memorize all the commands and all the code as I'm typing, because of course everything I do here is going to be in the code lab. So it's just for you to follow along and get an appreciation of what's happening. Okay, so we say Firebase login, but because we're in Gitpod, we need to pass this flag called no localhost. Right? Say no to that. It's going to send us a link. Click that link. Now ask me to sign in. Allow. Go and copy this token. Then you could go back to the CLI and paste that token in. And then you'll be logged in to the Firebase CLI. I think I logged in with the wrong account. I'm going to try that again. Oh, okay, that's fine. Next. So next we're logged in. Next, we want to initialize the app. So the Firebase CLI is logged in, but it doesn't know exactly which project we're talking with right now. So we have to do that by running this command, Firebase init. To ask us what features we're looking to use in this project in the workspace. We're really interested in hosting, so we just go down with the arrow keys and tap spacebar to select, and then enter. And we want to use an existing project. Let's go with demo project, the one that we created. Just press enter for this, enter, enter, and enter. So now the CLI knows which Firebase project from this dashboard that we're currently working on. Now, the next step we want to do is set up performance monitoring. Okay, so inside of this file, the workspace, everything inside of this public directory will be uploaded to the cloud as your website. Okay, so we have an index.html, we have a 4.4, and a CSS main and Java main.css and a main JavaScript file. So we're going to go inside index here, and in order to get performance monitoring set up, we have some CDN links that we need to link. Let me just go back to the code lab here. So we're going to need to get this beforehand, right? This link is a third-party JavaScript polyfill that allows the browser to measure a metric called the first input delay. So it's essentially how long the page takes to load. So we're going to include that our head because we want to start that timer as soon as possible. So we're going to put that here. Next, we have these scripts, which are the Firebase libraries. And we could put this at the bottom of the page because we don't really want the execution of these scripts to block the render of the page. So I'm going to just copy everything here. Put it down in the body. Right, so these are just exactly straight from the documentation for setting up performance. So I'm not doing anything custom here. This is just how you just include performance in your app. Right, so you just link this CDN script and then you link these other scripts. This script is the Firebase base library. This is the library for performance. And this is the library that initializes the web app with your projects. It passes your web applications config to the Firebase library, so it knows which database it's talking to, which hosting environment, and what have you. Now these links are relative to the hosting URL of your deployed app, right? So these links are these directories you don't actually create. Once your app is deployed on Firebase hosting, these libraries will be actually hosted relatively to where your application is also hosted on the internet, if that makes sense. Okay. So if you're not hosting this app on Firebase, these links won't work. You probably need to replace them with a CDN, links to CDN, or include the library on the file system of your web server. So next, we're gonna try serving it. So when you're developing a web app, you like to see how it looks like while during development. You won't be able to use any normal server because due to what we're doing in the previous slide here, because we're using these libraries that are available in the hosted environments, we can only use the Firebase serve command to properly load these libraries in. Okay, so I'm gonna go ahead and type that in here. Firebase serve. Right, it's going to tell you it found something open, working on port 5000. So you're going to click open, make public, and then open browser. Then you're going to see your application here. So this is just a blank application, but this is how the application would look if you deploy it right now. So we're going to go back. That's how you could serve for development. Next, we're going to do deployment. So I'm going to make a new terminal. So to deploy to Firebase, simple command, Firebase deploy. Just wait for this terminal to become interactive. Thought seems to disconnect for a second. Okay, so I'm going to cancel the save command and run the Firebase deploy. So it's going to take everything in your directory and then ship it across, and then it's going to give you the URL for your newly deployed application. So you could control click it inside here and it will open it. And this is the application here, hosted over HTTPS. And just like that, we have created a web application, linked some analytics and performance monitoring, and deployed it. So where can you go to actually monitor the performance? Well, you have to return to the Firebase console. So I'm going back here. And if you were to now browse to the, that is, keep forgetting where this goes. Performance. Supposed to be. So reload. Quality. There we go. Performance. You should then see that performance monitoring, the SDK has been set up. But you have to wait a little while for it to start to aggregate data. But in the code lab, I did give a little snapshot, a little idea of how it looks over here. So it covers metrics like something called the first paint, how long it takes to paint the page. Then you have something that's the first contentful paint, first input delay, things like DOM, content loading event. I don't know the difference between most of these metrics, but of course, Firebase can explain them to you and lead you to other resources for the explanation. Things like DOM interactive and the load event end, right? So, and then you could really drill down based on where they came from or what kind of devices they're on. So it really gives a good idea, a good look into how your web application performance is for the different audiences. And that is the conclusion to the first code lab on um, Firebase hosting, analytics, and performance monitoring. So I'll now just take a pause for questions. There is a 10-second delay, so just keep that in mind. So again, as I said, these code labs will be made available, and what we really try to do is really break it down and provide a guide, step-by-step guide. And what really helps is that Git pod environment, because we can give you that additional context in our steps as well, right? Because so we know the environment that you'll be working in, and you can just need to follow the steps we give, and hopefully when you're able to reproduce the steps and get the same outcomes. So just to note that there is a difference between different hosting models. So what Firebase hosts in here is what they call statically served hosting, meaning that the only kind of websites you can have on Firebase is what you call the static files, right? Not exactly static websites, but static files. So only HTML, CSS, and JavaScript can be hosted. Things like backend server-side coding and backend server-side languages is not supported with Firebase hosting. So won't be able to do anything like PHP scripts inside hosting or Node.js or even Python, anything like that. You would have to probably deploy somewhere else and have the front end, the statically served part of the site, talk to it separately. Or if you have some backend logic, there's Firebase functions for that. So I'm just going to hold out a little bit longer in case we have any questions, just being mindful of the delay. And then we will go into the second code lab, which is on Firebase extensions. Okay. So now we're going to move on to our second code lab here, which is on extensions. right? So as we mentioned, Firebase extensions are third-party Firebase functions essentially that you can just drop into your application, and they just provide you a way to add in, add in, certain specific features that solve problems in your solution. So in this collab, we shall add an extension that automatically sends emails to users. It's going to continue from the same project that was done in the previous code lab. But however, I must mention that it seems SMTP security has changed recently. So when I originally played around with this extension, I was able to allow programmatic access to my Gmail account, which would then send the email on behalf of the extension. But it seems to be not so easy these days, right? Security features and whatnot. So every time I try to test this functionality, I'm getting it's being blocked because of Google security. Even tried with Yahoo as well. So I wouldn't actually have a full demo of email working, but I'll show you how you set it up. If you use a service like email service like SendGrid, however, I'm sure you can get it working all the way, completely sending those auto emails for you. So just to keep that in mind. But nevertheless, we'll still go through how these extensions are set up, how we configure and set everything up. So first, we need to create a Cloud Firestore. So as we said, there are two NoSQL databases in Firebase. You have the real-time database and the Cloud Firestore. This extension will require the Cloud Firestore, so we have to go and add it to our project. So we go here in database, create database. This is a really important thing. Some people overlook is the security rules, because the way the Firebase SDK for web is, it is often very easy. Often very easy to get your Firebase config from a website, right? Especially if you use the Firebase, the built-in library, right? So your main line of security is the security rules. Okay, so a lot of people sometimes just leave it in test mode and they leave the entire database readable and writable by anybody who has access to an internet connection, right? So the security rules is your first and primary line of defense to locking down who can access what. Okay, so we're going to leave this in production mode, but we will update these rules to show how we can lock down only a portion of our database for public read and writes as we see fit in our application. So we're going to leave that. We can leave this location. Done. So it's provisioning this Firestore first. So thanks again to Arthur for answering the questions in chat. Right, so here we have our collection, and we're going to go right to the rules directly. And we're going to update these rules to say only a certain collection or database will be read and writable. So let me just think we're on this page here. So these are the rules you're going to use. Saying that there's a messages collection and we're allowing public rights to it, right? Because it's a contact form. So anybody should, put the content, should be able to just put their data in the contact form and, send data to you. So we're going to update our rules accordingly. It's a little weird here. Publish. So now we're saying we're allowing public read and writes to the messages. You can probably disable reads, but you just leave it to public rights by now, for now. So when you click publish, those rules will then become active. So if we go back to our database, you see that it's initialized. And now we're going to get some code on how we could programmatically send data to Cloud Firestore. So we're going to go back into this workspace here. But if you created a new workspace, you'll have to do that login step again, and you have to do that initialization step again, right? And we're going to go into index.html, and we're going to add some markup and JavaScript to this page to get that login form working. So looking back over here, we have this first snippet, task 2.1, some markup. Now, this is using, the page is using a library called Bootstrap Material. So all of these extra classes, all of these other tags, this is just what is required to get that visual presentation that Bootstrap Material provides. Okay. The main thing you really need to take away is that we have a form with ID contact form, and it has these fields that are given names, right? So we have a data input with the name, a data input with a name, email, and message, right? So we have a form with fields, name, email, and message, and that's all the JavaScript is really cares about. So I'm going to copy that. I'm going to put that. I guess we could put it here. Oops, too much. What's that mean? Yeah, that markup. First, we want to see the results of that markup, so we're going to go back and run Firebase serve. Spell. Open back any preview. And now we have a neat little form. Okay, so we have a basic form here using Bootstrap Material. Next, you want to add some JavaScript. Oh, yeah, you want to add some JavaScript to ensure that the Firebase library or the Firestore library that we're interested in is included. So we already have Firebase app. I already have init, but we don't have Firestore yet. So I'm just going to go right ahead and include that. Thanks. And now we're going to add some JavaScript to actually get the data and send it to the Firestore. I'm going to copy all of this. We'll talk about this. So this is the first line that initializes what they call the Firestore object. So we will use this DB object to do anything we want to do in the Firestore, reading and writing, referencing collections and documents, right? Then we create this function, which is an event handler, which is said to be an event handler. This is some JavaScript theory now. Event handler, which is responding to the submit event of the contact form. So if we look down here, there are many different ways to do this implementation. So this is just one way, of course. That's just how JavaScript is. But here we are referencing the contact form using document.forms. We give it the name contact form, ID, and we add in an event listener. So we're essentially saying whenever contact form is submitted, we want to call this function. And anytime a function is passed to an event listener, it's said to be an event handler. So event handlers always receive this event object. And what that allows us to do is that the function can then know, well, which element the event happened. The event occurred on. So that's what's going to happen here in form equal event target. Because this function was attached to the submit event of the form, we can actually get the form element inside the event function. Okay, so I hope it's not too complex, but we're just going over some JavaScript syntax here. This prevent default, what this is doing is in any HTML5 form, the default behavior when you click a submit button is actually to cause a page redirect. And it will redirect to whatever page that you set in the action attributes in the HTML form element, right? But we're not doing that. Actually, we just want to do something else from the default behavior, so we call event.prevent default. Okay, so that's what's happening here. Over here again, the form, and if we say form.elements, we get the form fields of the form. And now we're just taking out the data from the form fields in these lines and wrapping it up into a JavaScript object. So we get the name from the name form field, we get the email from the email form field, and we get the message from the message form field and wrap it up into this data object, which will represent the structure of our document that we want to add to Firestore. We log it just to see it back in the console log. And we call this line here to add and send the data to Firebase Firestore. So it's db.collection, and you give it the name of the collection. We call our collection messages, and our security rules allow public rights to messages, so this should execute. And we call .add, right? So when you say you need to add to collections, but if the reference is pointing to a document, you'll use set instead. So you use set to create individual documents, but if you want to add it to a collection, you'll use add. And when it's successful, they'll give you back a reference, which you can then get an ID. So you just for if you want to reference it later on in your app, you get an ID of the created document. We do an alert, message received, and then we reset the form. So hopefully the syntax is not too scary. It's not something you need to memorize, just something you should be able to just read and just get appreciation for what it's doing. Because of course, there are many different ways you can do this in JavaScript, at least. So I kind of gave an explainer of everything that's happening over here. So we're going to go and test this form now. Maybe I can open this out in a new window. So I can open up the debugger. So we'll say this is a message from Bob at mail.com. So this could be like your typical contact form for a website, right? You have your own personal website and you want people to shoot your email really quickly. This is a simple contact form. Submit. This doesn't look too good. All right. Whoops. I didn't actually add the code. So this code here, I've been talking about it, but I never added it to the app. So let's go into main.js. Add that code over here. Okay. But if you notice, I guess this is a nice thing we could see that the default, because we didn't have that code, we weren't able to prevent default, and the default behavior of an HTML form when you do submit is to take the form data and paste it back into the URL as query parameters because it's a get form, right? So now we wanted to do something else, and we will see that would work. Gee, just getting the error here about the other script. Let's remove the curve stuff we had before, just to make sure we don't run into any. Okay. Submit. And here we say the data that we had in the form being logged to the console. We can see that the message was sent successfully because we actually get back that ID of that document. So we can go into back to our project. If we reload the database, you would see that document ID there and the data of our form in Cloud Firestore. So that's how you create a form to send data to Firebase Firestore. Right? So it's a one-liner, more or less, to send the data is db.collection.add. If you want to add it to a collection. Okay. So now we want to add the email extension. So this again, this extension is only available on the Blaze pricing plan, right? So the default pricing plan for Firebase is the free, the absolute free. But in the Blaze pricing plan is, well, what it does is as if you cross the free tier allowance, it will actually, you'll be charged as you go, pay as you go, right? But for the Firebase functions is concerned, you only start to pay after the first million invocations. So I experiment a lot with the Blaze plan, but I never have to pay anything. But it does mean that you need to, set up a Google Cloud billing account, credit card, and all that business. Okay. So can I'm going to skip this part out because, as I said, it doesn't really work with the Gmail. But what you would do is you would go to the extension over here, and extensions. Look for the trigger email, install. Next, update. So I could put it. You have to put it as Blaze. Up, up, up. Yeah. Let's not do that right now. All right, good thing I have the screenshots. And after you set up all of that, they're gonna give you this dialog here to configure the extension. So you need to set the function location, and you have to set this thing called the SMTP connection URL. So when I got this extension to work in the past, all I really needed to do is go in Gmail, allow SMTP access, allow insecure apps. But of course, I won't use it with my personal Gmail account and make like an additional test Gmail account. And I can put the username and password in here. You select which collection, if the extension has to look to to get the messages, and then you could set things that what would be the from address from the email that the receiver receives. This handlebar thing, we'll talk a bit about it a little lower. So when you set up all these things, you could then manage, the extension will then be bootstrapped, and then it would look something like this on the dashboard. You click this button to manage, and they will tell you how to set up the extension, how to use the extension, right? The major thing for using the extension is to understand the structure of the data that you need to put in the collection that the extension will be looking at. So for instance, the extension will be looking at that messages collection, and you need to really structure your data in a very specific way to get it to actually work. So the next code snippet here, it gives you the update. So how you have to structure your data for it, to get working. So all we have done here is, instead of wrapping up these fields into an object, we put them in these separate variables. And then we have changed the structure of the data. So the extension is going to look for certain things. It's going to need to see a list of emails to actually send the email to. You have a CC field as well. And then you have a message. Right? In the message that you send, you're going to need a subject and an HTML body, because emails do support HTML, so you're allowed to type HTML inside of the message body. Now, what you can do from here is use handlebars JS template syntax, right? And what is a template syntax? Well, before ES6 template literals came around, this fancy syntax, they were libraries created to allow you to add variable values in JavaScript variables into strings. right? So handlebars are just one of them. But I didn't really need to rely on that. I just use ES6 template literals. And ES6 template literals is simply the usage of these backticks, which is that this kind of quote on top of the tab button and this dollar sign and curly brackets to be able to embed the values of your variables into a string. Okay, so we just restructured the data a little bit. I have the name of the person in the subject field. I also put the name of the person in the body of the email and the message that they would have sent in the form. And then we just send it along to the messages collection, right? At that point, typical experiences after you implement that and then actually use the form again, the data in the form will actually create a trigger an email and you'll receive an automated email with whatever you sent here in the payload, right? I've been using this on my personal website for a while, but only just yesterday when doing this, preparing for this code lab, I realized that security SMTP access to Gmail no longer works as easily as before. Okay, so that's more or less the conclusion of our second code lab. That's how you can use a Firebase extension. There are other nice extensions like URL shorteners. I can go and browse them here. You could translate text. So what you would do, you'll take text and throw it into your Firestore, and then after a little while, it'll be automatically translated. Things like shortening URLs, syncing with MailChimp, and resizing images. And resizing images, I think, is a really important extension because it could really go a long way in the performance in your web application. Many applications are slow simply because they don't optimize the images. Right? There are many different devices which may visit your website, and sometimes your image has too many. It's just too big for the client that's browsing it. It's unnecessarily too big. So it's always good to have different sizes of images on the server and then ship optimal size images to the client. And this function really helps with that because it will create different size versions. And then you can use HTML image source set to decide which is the optimal image for the client. And that really goes a long way in helping the performance. So I'll stop there for any questions. I'm seeing that the chat has had a lot of back and forth with questions anyway. But any questions with respect to this code lab that you want me to look at, take a pause. Questions? Okay. So that more or less concludes our morning session of the GDG study, Firebase study jam from GDG Port Spain. Join us back in an hour or so, around 12, just overall 12:15, and we will start back with Arthur Thompson's session on Firestore and functions. Okay, so thanks again for joining us. I'll see you again at 12:15. Okay.